Binary search, be it school, be it college, array, tree, binary search tree, you have heard it everywhere, even in the interviews. Today I'll be explaining it in the most simplest way you will find on the internet. Suppose you bought a bike and you parked it outside your home, you slept very peacefully, and the next day you find that bike is not there, it's stolen. So what you do, you have a CCTV there, you go to file a police complaint, police asks you to provide a visual proof, you go check the CCTV footage, but you don't know when your bike has been stolen, but you know it's been stolen on a particular day, there are 24 hours. Now you have to find when was the bike stolen. There are multiple ways. The first way, you check the whole recording starting from 0 hour to the 24 hour, wherever the bike was stolen you find it, but it's not the most efficient way. This is called linear search. You are linearly searching the recording here, where is the point you are finding. Now what binary search says, you are seeing the recording, there is 0 to 24 hours, you go to the middle point, that is 12:00, you check if the bike was still there, and you see yes, bike was still there, so it's not stolen before it. Now you have to check only in 12 to 24 hours. Now between 12 to 24 you go to the middle point, that is 18:00. Now you check at the 18:00, that bike was not there, which means it was stolen before it. Now you know that the bike was stolen between 12 and 18, then you go to the midpoint 15 and you see that bike is still here, which means that it was stolen after 15 but before 18. You can notice that your space is reducing. Now you have to search between lesser space. Initially, if you do linear search, you have to check between whole 0 to 24 hours, but in binary search what you are doing, you just go to the middle point. If the bike is there, it means that it was stolen after this. Half of space is gone, you don't have to look into it. You are making it efficient this way. So in the timeline, you keep going on the midpoints, finding if the bike was there, if it was not there, and reducing the space every time by half. First you have to check in 24 hours, then in 12 hours, then in 6 hours, then in 3 hours, and it will reduce. That's why the complexity is logarithmic here, because it is getting divided by 2 in every search. So the complexity of linear search, because you are checking the whole recording in this example, it's O of n, but in binary search, every time your search space is reducing to half. So it's log n in the case of binary search. Now let's take this example to programming. If you want to find an element in an array, but consider here, array must be sorted, because in the recording, you know, if bike is still here, it will definitely not be stolen before this. Now keeping this in mind, go to the array, you are finding a number. Let us suppose there are 100 numbers and you are finding where is 60. You go to the midpoint and the mid number was 50. If the array is sorted, you definitely know that 60 will not be before it. So this condition is really necessary, that the array must be sorted. So you can know that after the midpoint the number exists, before it definitely not exist. Your search space have been reduced to half. You again go to the midpoint, you check if your number lies after this or before this. Before this, you search in this space, and again the search space divides by half in every iteration, and you will find the number faster than linear search. So here was a quick explanation of binary search. If you want me to explain the code of this, please do let me in the comments. और अगर आप चाहते हो कि मैं हिंदी में भी explanation बनाऊं, तो बता देना.